much. Hi, everyone. So I'm going to talk about what determines the value of our beliefs. And so our beliefs, that is our internal representation of the world and ourselves in it, is fundamental to who we are. Now, our beliefs are not simply formed by absorbing all the information around us in a passive manner, but rather we select which information to expose ourselves to. So we decide which article to read, which question to ask, who to follow on Twitter. And those choices reveal the value that people assign to beliefs or the preference over beliefs. So I'm going to focus on those choices. And I'm going to suggest that traditional frameworks of learning and decision-making cannot fully account for those choices. So traditional frameworks are grounded on the idea that people build an internal model of the world for the purpose of informing their actions to help them achieve external goals, such as attain food, mates, money, and so on. So for example, if I believe vaccines are safe, I'm more likely to get vaccinated and therefore more likely to stay healthy. So beliefs are formed by observing these outcomes and also learning from others. And there are two assumptions inherent in this model. So first, the more accurate my beliefs, the better, because accurate beliefs will lead to greater rewards. And second, that my goal is to achieve these external rewards. So the large majority of tasks that scientists use will offer subjects external rewards, such as money for humans or juice for animals, contingent on performance accuracy. But this account doesn't really convey the whole story. So in real life, inaccurate beliefs can often lead to greater external rewards than accurate beliefs. So for example, it's been shown that in some environments, overestimating one's ability can lead to greater rewards than accurate estimations. Another example, the belief in God is related to greater social supports and some measures of physical health. So inaccurate beliefs can lead to better external outcomes. But that's not the only way inaccurate beliefs can lead to greater rewards. So the brain does not simply treat beliefs as tools to obtain external outcomes, but as an important source of direct internal outcomes that can be rewarding and punishing in their own right. So for example, it's internally rewarding to believe the future would be bright rather than dark. It's internally rewarding to believe you're correct rather than incorrect. It's internally rewarding to hold beliefs with certainty. Uncertainty can cause anxiety. And such belief will trigger a neural reward signal that is similar to, or perhaps identical to, the one that is elicited by external rewards. Now, if this is true, then that agents should take actions such as seeking information that will enable them to form these internally rewarding beliefs. So let's look at one such example. So this study was conducted by my former PhD student, Caroline Charpenter, and it's analogous to a real-world situation in which you receive an envelope, perhaps containing a decision on a manuscript, and you need to decide whether to open the envelope or keep it closed for now. Now, your decision is not going to change the outcome. The manuscript has either been accepted or rejected, but it will change your belief of that outcome. So our study wasn't about manuscripts, it was about money. We had blocks of trials in which on every trial, this subject could either win a pound or not win a pound, and blocks of trials where on each trial they could lose a pound or not lose a pound. What they had to do is simply say whether they want to open the envelope to see the outcome or not. And whether they opened it or not did not change the external outcomes. We will give them the money in all the envelopes, regardless of whether they open it or not. However, to help them make a decision, we show them a pie chart that gives them a clue about what's inside the envelope. So this pie chart, for example, says you're 80% likely to win $1. Now, this study's kind of task is interesting because people can't change external outcomes, but they can change their internal outcomes. And the question is, how do they do that? So what we found was that despite the fact that information had no instrumental utility, that is, people can't use it to gain more money or lose less money, they still wanted to know. And the more the information could form rewarding beliefs, the more they wanted to know. So what you see here on the y-axis is a probability of seeking knowledge, that is a probability that they want to open the envelope. And on the x-axis is probability of gaining or losing. And so if you follow the orange line, you see the more likely they are to win, the more they want to know. And if you follow the purple line, you see the more likely they are to lose, the less they want to know. And you may notice that there's this curvature in the line, and that is related to the fact that there was an additional boost for wanting to know under uncertainty. So uncertainty is greatest at the 0.5 mark, right? When it's 50-50, you don't know what's going to happen. And so we show this by conducting a linear model when we're predicting the choices that people make, whether they're going to open the envelope or not, from two factors. Number one, the likelihood of receiving good news, which is measured by the expected value of the lottery, and the amount of uncertainty, which is a standard deviation of the outcomes. And you can see that both of these factors significantly predict people's willingness to know. Okay, so people take actions to form positive beliefs that are also certain. Let's take it a step further. Would people trade external rewards for internal rewards? So for example, will they be willing to pay money to observe information that will generate positive beliefs? And maybe they will be willing to pay money to avoid punishing beliefs. So we looked at this at a second study, and this was originally conducted by Caroline and then also replicated with some changes by my PhD student, Valentina Villani. So in this task, participants get an endowment, and they use the endowment to buy stocks in a stock market that we simulate in our lab. And then on each trial, they either see the market going up or they see the market going down. And this gives them a clue about their own stocks, but they don't know for sure because they only have a few stocks in the market. And then we ask them, do you want to know how much you're worth at this point in time? Again, information is not instrumental. You can't use it to buy stock, sell stock. But if you want to know, you can. And there's a little trick. If you want to know, you have to pay us. And if you don't want to know, you also have to pay us. And the more you pay us, the more likely we are to honor your request. So if you say, I'm not paying you anything, then it's 50% that we will show you your outcome. So let's say you want to know and you say, I'll pay you 60p to know. It's probabilistic, but most likely we will tell you how much you're worth at that point in time. Let's say you don't want to know and you say, I'll pay 90p not to know. Again, it's probabilistic, but most likely we will just not let you know what you're worth at this point in time. So what we found was that on about half the trials, participants paid us, and on half the trials they didn't. And out of those trials that they did pay us, about 2/3 of the trials they paid us for knowledge and 1/3 for ignorance. And of course, the interesting question is what drove their decisions? So once again, we found that people wanted information more when it could produce positive beliefs. So what you're looking at here are trials when the market is going up. So on the x-axis is how much is going up on this trial relative to the previous trial. And on the y-axis is willingness to pay for information, coded positively if people pay for knowledge and negatively if they pay to avoid knowledge. And you can see the more the market is going up, the more participants want to know. What happens when the market is going down? When the market is going down, participants don't really want to know much, right? They're not willing to pay much. Now, interestingly, on average, they do pay a little bit for knowledge, right? They don't pay us to avoid knowledge, although some subjects do. And so they're paying a little bit because still certainty has its value. Okay, so it looks like people will trade external rewards for internal rewards. What if the two were competing? That is, you could take one action to increase the likelihood of internal rewards and another action to increase the likelihood of external rewards. So we tested such a situation. This was a study that was conducted by my former PhD student, Philip Gasarias, and my former postdoc, Donald Cahill. So we created a task where participants could bias their beliefs by controlling the evidence they sampled. So they could choose to form internally rewarding beliefs that are not necessarily accurate at the expense of external rewards. And the way that it worked is on each trial, the subjects either visited a phone factory or a TV factory. So phone factories produce mostly phones and sometimes by mistake produce TVs. TV factories produce mostly TVs and sometimes by mistake produce phones. What the subject needs to do is simply look at the products moving along the conveyor belt, and whenever they feel they know what factory they're in, they press a button and tell us whether they believe they're in the phone or TV factory. And we pay them for accuracy. But again, there's a little trick. We tell them that they have stocks in one of these factories. Let's say this subject has stocks in the TV factory. Every time they happen to visit the TV factory, they'll get a bonus point. And every time they happen to visit the other competing factory, they will lose some points. But they can't control what factory they're in. That's controlled by MATLAB, right? So the best they can do is just be as accurate as they can. So what we found is that participants sample less evidence before reaching the conclusion and the belief that they are in the desirable factory. So what you're looking here on the y-axis is the amount of evidence they sampled over time. And on the x-axis is a proportion of stimuli that is consistent with their response. And the important thing to notice here is simply that the blue line is below the red line. So they're gathering less evidence before reaching the positive belief that they're in the good factory than the punishing factory. And as a result, their beliefs are biased. So if you look at these psychometric functions, you can see that the blue line is shifted to the left. So this means, for example, when the amount of evidence you see is 50% good and 50% bad, about 65% of the time, the participants say, I'm in the rewarding factory. And when we fit the data to a drift diffusion model, we found quite a strong drift rate bias towards desirable evidence. So that is as if to say that every piece of desirable evidence had more weight than the undesirable evidence. There was also a little bias in their priors. So it's as if when they started the experiment, they already believed to a little bit of extent that they are in the rewarding factory, but this effect is quite small and not as stable. Okay, so it seems that people actively form internally rewarding beliefs, which are sometimes inaccurate, sometimes at the expense of external rewards. And the big question is why, right? How could this be adaptive? Is it adaptive? So one popular speculation has been that on balance, internally rewarding beliefs that are inaccurate, such as, for example, positive illusions, are adaptive on balance. So Daniel Dennett has called them design features. Eric Bandura has pointed to their increase in motivation and self-efficacy. So if I believe I'm in a good state, I put more effort to gain my goals because I think they're possible. Shelley Taylor provides data to show that there's a correlation between positive illusions and physical and mental health. And Martin Seligman provides evidence for causation. Now, everyone compares these benefits to the costs of having inaccurate beliefs and underestimating your risk, but they conclude that probably on average, the benefits outweigh the costs, sorry. Another view that's a little bit more nuanced is whether these types of beliefs are adaptive or not is actually contingent on the type of environment that you're in. So in relatively safe environments, like you and I are in today, perhaps the benefits outweigh the costs, so it is adaptive. But in relatively dangerous environments rife with threats, the cost of having inaccurate beliefs and underestimating your risk will be greater, right? So in those environments, it's perhaps not adaptive. So our view builds on this, but is somewhat different. We're suggesting that the brain prioritizes either internal and or external rewards based on their value in a specific environment in an adaptive manner, and uses flexible learning mechanisms to do so. That is to say that if you're in a relatively safe environment, you might prioritize internal rewards, sometimes at the expense of immediate external rewards. But in a dangerous environment rife with threat, you might prioritize external outcomes, sometimes at the expense of internal outcomes. And you can prioritize one or the other by adjusting how you seek information and how you use that information to alter your beliefs. So to test this, what we're going to do is we're going to put subjects in a threatening environment, and we're going to see how they're building their beliefs. So we did a few studies to look at this. I'll tell you about the last one. This is from my PhD student, Laura Globig. So she brought people into her lab, and she had two groups. One group was a threat manipulation group. She told the subjects that they're going to have to give a talk about a surprise topic that we will give them. We're going to rate them. We're going to judge them. We're going to tape them. We're going to put it on YouTube. And then we had another group, which was the control group. For this group, she said, you're going to have to write an essay, but no one's even going to read it. To make sure the manipulation works, She asked them to report their stress levels before and after the manipulation. And then we gave them a task, which I'll show you in a second. So first of all, just to say, yes, the manipulation worked. In the threat group, stress was higher than after the manipulation relative to before, but not in the control group. Okay, so then she gave them the factory task that I just told you about. And what you can see that in the control group, again, they required less evidence, they sampled less before reaching a desirable conclusion. But in the threat group, this bias went away. And looking at the drift diffusion model, she found, again, a large drift rate bias towards desirable evidence in the control group, but no difference, no bias in the threat group. In other words, when people were under threat, they changed the way that they accumulated evidence and used it to alter their beliefs such that there was no longer a bias. And I think what's interesting is that the threat had nothing to do with the task. The threat was a social threat. They had to give a talk. The task was about money and phones and TVs. And yet a stress signal altered immediately the way the people accumulated information. Okay, so what we've kind of talked about here is that people take actions to form internally rewarding beliefs, sometimes inaccurate, sometimes at the expense of external rewards. But this is sensitive to the environment that they are in and seems to be relatively adaptive. And the hope is that what we take away from this is a need to move beyond the traditional approach in which we focus completely on how people attain external outcomes and move to considering these internal outcomes, which are a direct consequences of people's beliefs. So we need to model and empirically test the value of such outcomes. Now, this is, of course, more challenging because these kind of outcomes are not tangible, but I think clearly necessary for understanding human behavior. And I'll just finish by thanking the students that did these studies, our collaborators, as well as our funding. Thank you.